We are going to continue doing more with the ellipse, so still in section 10.1. Today we're going to be graphing when we don't have the center at the origin, and we will continue to write equations in standard form. So a quick reminder of yesterday, remember to be in standard form means that we have two fractions added together and it's set equal to 1. A squared and b squared will always be our denominators, but a squared is always greater than b squared. Notice that these pictures show us having our ellipse in a spot other than the origin. And so remember, the ordered pair, HK, which are the numbers that are in the parentheses with the x and the y in the numerators, are going to help us get our center. But we always take the opposite signs for both of these in order to create that center. If you look at the pictures, remember your center is always going to be lined up nicely with the vertex from either end of our major axis, as well as the foci that are within our picture. The foci, remember, we get by calculating c squared equals a squared minus b squared. So let's take a look at this example. We want to graph x plus 1 quantity squared over 9 plus y minus 2 quantity squared over 4, and that equals 1. It's in standard form because we have two fractions added together equal 1. A squared is always the bigger term, so 9 is bigger than 4. Take the square root of 9. A is 3. 4 represents b squared. Take the square root. B has to be 2. To get our c, we have to use our formula that a squared minus b squared gets us c squared. So c squared equals 9 minus 4. That's 5. I have to take the square root to get c. So the square root of 5 is c. My center comes from the numbers that are in the parentheses with the numerators. Remember, ordered pair, x is first, y is second. So I'm looking at the number that's connected to x first. That's going to represent our h value, but I take the opposite sign. So -1. The number that's in the parentheses with the y represents our k value. I take the opposite sign. So our center is at -1, 2. So I'm going to plot that point on my graph. Remember, if you are going to be creating your graphs and you want to have something other than going up and down by a distance of 1 on your axes, make sure you are labeling it. My foci, remember, are going to be lined up nicely with my center, but we need to know which direction are these foci going. Is it going to be horizontal or vertical? Because my bigger number is underneath the x's, that tells us that we are going to be dealing with a horizontal ellipse. So I know that that means that I am going to be taking, for my foci, the c value, and I'm going to be adding and subtracting that on to the first number in my center, which helps me move left and right. So -1, we are going to be adding and subtracting to get two different ordered pairs, the c value, but we're not moving up and down, so the second half of our center remains the same as our foci. If I want my major axis endpoints, once again, we're talking horizontally, so that means that from my center, which at -1, I'm going to take my a value, and to move horizontally means I'm adding and subtracting my a value on to the first number in my ordered pair of that center and keeping the second one the same. Now, because this doesn't deal with square roots, I do want you to actually calculate that out and give me those two ordered pairs. -1 plus 3 is 2. So 2, 2 is one of my major axis endpoints. -1 minus 3 would be -4. So -4, 2 is the second one. Eccentricity is always c divided by a. There's no way that I can simplify that down any further, and that's my eccentricity. So from the center, I know that 2, 2 is over here, and that's an endpoint of my major axis, -4, 2. Everything's lined up nicely. And so my foci, I can approximate this. If I have -1 plus the square root of 5, well, that's approximately 1.2. So I know that that's 1.22. So it's a little bit past, but notice how it is lined up with my center. And if I was to take -1 and subtract the square root of 5, I would get approximately -3.2. So -3.2, 2 would be the other one. To finish out to get the shape of the ellipse, it technically means that I need the minor axis endpoints. And so because that is going to be dealing then with moving up and down, I know that I'm going to keep, because it needs to be lined up nicely with the center, I'm going to keep the first number of the center as is. But now that second number 2, I'm going to have to add and subtract my b value onto that. So that gives us an ordered pair of -1, 2 plus 2 would be 4. So -1, 4 is going to be part of my ellipse. And -1 and then 2 minus 2, that would give me the ordered pair of -1, 0. So connect your endpoints from the major and the minor axes. Ooh, do better than what I just did. And then notice that your foci are inside that ellipse, and there's my graph. There are going to be times when you have to put your equation into standard form, and it's not just the simple let's divide. Okay, here we are going to have to complete the square, something that we did a lot of last semester. So in order to complete the square, notice that I've got a bunch of terms that have x's and y's, and then there's a number that doesn't have any variables. I'm going to move that number over to the other side. And then I'm going to rearrange the left-hand side by putting the x terms together. So it's going to be 4x squared minus 32x. All right. Then I'll have my positive 9y squared and then plus 36y. And then that's going to equal 0 minus 64 is -64. All right. So in order for us to complete the square, I am going to have to deal with both of these terms, but in order to complete the square, I'm going to have to get rid of the lead coefficient in front of the squared terms. So 4x squared minus 32x, there's a 4 in front of the x squared. So I'm going to factor that out of these two terms, and that gives me then x squared minus 8x, and then I'm going to leave a spot for me to actually complete the square. Plus, between those two terms, notice 9 is in front of the y squared. I'm going to factor that out. We'll have y squared plus 4y, and then I'm going to leave a spot for me to complete the square. And then that's going to equal -64. Now, because I'm going to complete the square not once but twice on the left, I'm going to have to add those numbers onto the right-hand side to keep my equation balanced. Remember, in order to complete the square, I look at the number that's in front of the non-squared term. I'm going to divide that by 2 and square it. So -8 divided by 2 is -4, but -4 quantity squared is 16. Over here, I'm going to take the 4, I'm going to divide it by 2, and I'm going to square it. 4 divided by 2 is 2, 2 squared is 4. Now, here's the thing. I'm not actually adding 16 and 4 to the other side because 16 is not what I'm really adding. I'm really adding the number that's out in front, which is 4, being then distributed back to the 16. So I have to multiply those two numbers together, and that's going to give me 64, and that's what I then added over to the other side. So this 64 came from me multiplying 4 and 16. Over here, it's not that I'm just adding 4, but I am going to have to multiply that outside number that I factored out, and 9 times 4 is 36, and then that's where that number on the right goes. All right, so now that I've done completing the square there, I'm going to still have that lead coefficient of 4, but now this trinomial is factorable. Okay, what multiplies to 16 but adds to -8? Well, that's -4 and -4, or x minus 4 quantity squared. Because remember, -8 divided by 2 is -4, and then I squared it. That number prior to squaring is the number that goes in the parentheses. Okay, plus 9, but I can actually factor y squared plus 4y plus 4. Well, what multiplies to 4 but adds to 4? That would be 2. So y plus 2 quantity squared. Because once again, 4 divided by 2 is 2. And notice how the 2 goes inside of the parentheses. On the other side, when I add those three numbers, negative 64 and 64 cancel, and that leaves us with a positive 36. So then last step, because I still don't have it in standard form because my equation should say that it equals 1, and right now it equals 36. So I'm going to divide every single thing on both sides of the equation by 36. I can simplify down those fractions on the left. When I reduce, I'll still have that x minus 4 quantity squared, but now that's all over 9. Plus, I reduce, and I'll have that y plus 2 quantity squared in the numerator, but now that's all over 4, and now it equals 1. And now I have my standard equation for the ellipse, and now I can go ahead and I can graph it. Okay, so that's where this equation came from us completing the square. So I can identify the fact that the bigger number is 9, so that represents a squared. So that means that a is 3. 4 is my b squared, so take the square root, and b is 2. To get my c, I'm going to be subtracting a squared and b squared, and then I'll have to take the square root, and I get the square root of 5. My center comes from the numbers that are in the parentheses. Notice that h goes with x, k goes with y, but I'm changing the signs. So my center is positive 4, negative 2. Notice that the bigger number is below the x term. So that means that we are going to be dealing with a horizontal ellipse, which means that I'm going to be moving the value from the x of my center to get both the foci as well as the major axis endpoints. So if the foci means I'm taking the 4 and I'm adding and subtracting the c value onto it, and then I'm keeping the second half of my center as is. For my major endpoints, I'm going to take the 4 and I'm adding and subtracting the a value and keeping the second half of the center the same. Once again, 4 and 3 are numbers that I can actually add and subtract together. 4 plus 3 is 7. 4 minus 3 is 1. So these are the ordered pairs that I'd like you to identify. My C eccentricity is going to be C divided by A, and I can't simplify that down any further. Okay, notice that my center for negative 2 is down here. 7, negative 2 is over here. 1, negative 2 is here. They're all lined up nicely. Remember, technically, I want to identify the minor axis endpoints by leaving the first half of my center the same, but now focusing on the y values, moving up and down from the center. So that means that negative 2, I'm adding and subtracting the b value onto it. So I'm keeping the 4. Negative 2 plus 2 would give me 0. Keeping the 4, negative 2 minus 2 is negative 4. So there's the shape of my ellipse. And then lastly, if I wanted to actually then plot the foci, which I do, I'm going to estimate 4 plus the square root of 5. Well, that's approximately 6.2. So we'll have 6.2 and then negative 2. So foci right there. And then 4 minus the square root of 5, well, that is approximately 1.8. So that's going to be over here. It's still down at negative 2 for the second half. My foci are all lined up nicely along with my center. And there's my graph. Let's take a look at a few different problems where you have to write your equation in standard form. So notice that we're talking about giving us foci. So that means that these values are going to help me identify C, okay, because it is going to be important for us to identify A, B, and C here. So the foci ordered pairs are going to help me get that. The vertices are going to help me get the A. Remember, your vertices and your foci, they are all lined up and your center is halfway between them. So it honestly doesn't matter which one of those pairs you decide to use. So say I use the foci, and I am going to take those two ordered pairs, and I am going to find the midpoint. So remember, the midpoint means that I'm averaging them together. I'm going to add the x values, and I'm going to divide by 2. And then I'm going to add the y values and divide by 2. That's going to get me essentially the center. So notice that -2 plus 2 is 0. 0 divided by 2 is 0. 0 plus 0 is 0. 0 divided by 2 is 0. Same idea if you would use the vertices. If you had done -3, 0 and 3, 0, you would have gotten a midpoint of 0, 0. And hopefully that makes sense that 0, 0 is the middle of both of those ordered pairs. So this essentially is our center, which tells us then when we are looking at our formula for an ellipse, there's nothing to add and subtract in the numerators with the x's and the y's. Okay, I know to be in standard form, I want it to equal 1. So now we just have to figure out what is our denominator. So because our center's at 0, 0, notice the foci, which helps us get C, it's going a distance of 2. Okay, to go from 0, 0 to 2, 0, we moved 2. Same thing if I had gone the opposite way. If we look at our vertices from our center, well, we moved a distance of 3. Your A value is going to be telling us where those vertices are, because remember, vertices are on the major x-axis, and so that would be a distance of 3. And so now to find B, I know that C squared equals A squared minus B squared. I'm going to plug in my numbers. So I'm going to take 2 and square it, set that equal to 3 squared minus B squared. 2 squared is 4, 3 squared is 9. I'm going to subtract the 9 to move it over. -5 equals -5 equals -B squared. I'll divide by that -1. So 5 equals B squared. So take the square root, and our B is the square root of 5. All right, so because our A values, notice that from the center, we moved the first numbers in our ordered pair. That tells us that we are moving and having a horizontal ellipse. That means that the bigger number has to fall under the x. So A squared would be 9. That's under the x squared term. We know that B squared is 5. That means that that has to go under the y squared. And here is my equation. Find the equation in standard form given the major axis is vertical with a length of 20 and the length of the minor axis is 10. The center is at 2, -3. All right, so something to help us out here. If I know that I'm talking about the major axis is vertical, that means that I know that when I'm writing my equation, wherever my y is, I know that my bigger number is going to fall under that. H and K are given to us. I know that H goes with X, okay? But remember, I'm taking the opposite sign. So X minus 2 quantity squared is why it's a positive 2 for my center. And Y plus 3 quantity squared, that's why -3 is my K. All right? So if I know that the length is 20, and that's dealing with the major axis, that means I am going to want to essentially set that equal to 2a, because from the center going in either directions is a distance of a. So like if I would just really quick sketch a picture, like here's my center from here to here, that distance is a. So from the center to this point, that's another distance of a. So it makes up 2 a's to get you that entire major axis. So divide that in half, and I know that a is 10. So that means square 10, and that has to go underneath the y term, because once again, we're talking about a vertical major axis. So that means my minor axis, being a length of 10, means that 2b has to equal 10, because it's the same idea. Here's 1b, there's 2 b's. That makes up then the minor. So that means that our b value is 5. Square that, and that goes underneath the x term. And here's my equation. All right, last example. We want to find our equation in standard form. Here is the endpoints of the major axis, 7, 9, and 7, 6. The endpoints of the minor axis are 5, 6, and 9, 6. All right, so doesn't matter which one of those sets we use, but we're going to use one of those sets to find our center. And so remember, to find our center means that I'm taking the midpoint of those. So I'm going to do it with the major axis. So because we're dealing with 7, 9 and we're dealing with 7, 3, I'm going to average the x values. So add them up and divide it by 2. I'm going to average the y values. So add them up and divide it by 2. Well, 7 plus 7 is 14. 14 divided by 2 is 7. 9 plus 3 is 12. 12 divided by 2 is 6. That's my center. Okay, so notice that my center, what didn't move? The x's didn't move. The y's are what are changing between the major axis and the location of the center. And so because it's the y values that are moving, that means that we are going to have a vertical ellipse. Okay, so that means that my bigger number of A is going to have to go underneath the y's. All right, so if this is my center, I know that it's going to be x minus 7 quantity squared over a number, and then y minus 6 quantity squared over a number has to equal 1. Once again, I know that my bigger value, which is A, is going to go under the y's. All right, so if the center, I know I'm dealing with a value of 6, pick any of the other two numbers in my major axis that are the y values, like 3. So how do I go from 6 to 3, or how did I go from 6 to 9? Well, that was a difference or a distance of 3. So that means my A value was 3. So square that, and 9 goes underneath the y. All right, so why did they give us the minor axis endpoints? Well, notice that with these, it wasn't the it wasn't the y values that moved, it was the x values that moved. So if I'm looking at my center, which starts at 7, look at one of the x values of the minor, and how did I go from 5 to 7? Well, that was a length of 2. So that tells me that my b value is 2. So square that, and that goes under the x. And here is my equation. All right, so I would suggest that you try this checkpoint problem. So pause the video, at least make sure that you know how to write that equation in standard form before you try the homework. Okay, so pause it, try it. So this is what you should have gotten. You should have ended up with an equation of x minus 3 quantity squared over 25 plus y plus 2 quantity squared over 4 equals 1. And then there's all the other information and the graph provided. All right, so that's us dealing with something not at the center, and we can still write equations.